Hello, hello. I believe we are live for the Hoot live stream. Are you excited about eBPF and get started with understanding and writing your own eBPF applications? Krisztian recently ported an eBPF application, I believe it's out of memory related application to BumbleBee. So I am so excited to have him back to our Hoot live stream to discuss eBPF and BumbleBee with him today. Yeah, Krisztian, welcome back. Can you introduce yourself quickly to the audience for any folks who are new here?
Yes, hello everyone. I was here a few sessions ago as a LastPass employee, and I'm here as a solo employee. It's great to be back, and yes, thank you for joining. We will take a look at my experience on porting libbpf application to BumbleBee.
Awesome. Very nice to have you. And even nice this time that you work for Solo. Last time you were back, you were on the Hoot. Actually, it's the very first Hoot that I run, I host is episode 20, one click Istio install using Helm. And I believe you joined Solo somewhere in April. So we're so excited to have you back. Before we get to the episode, let's talk about news quickly. So the first thing I want to share last week, the Hoot episode 28, the steps are published now. So if you are interested in the 25 plus minutes demo that Fasila and I shared, please check out our steps here. About workload selector, credential name in destination rule, auto SNI, telemetry, minimum TLS, telemetry, new additions to the telemetry API. So definitely check that out and follow along. The next news I want to share is, if I can get the thing out, is SD Time released their 100 best in show in software development, and solo.io made to the list of the category of API and integration for 2022. So very exciting, along with many other companies like TIPCO, Kong, very exciting to be on the list. William Morgan has published a very interesting article about his thoughts on eBPF, sidecar, and the future of service mesh. If you haven't checked it out, I definitely encourage you to check out. I'm actually a big fan of William when he writes technical thought leadership blogs, because he has that skill of explaining things really, really understandable for folks reading his mutual TLS Kubernetes guide. It's just a great blog. So it's really cool that in this blog, he talked about eBPF, how you should understanding eBPF and think about it in the context of multi-tenancy, how that's becoming a harder problem for eBPF. What are the areas eBPF is limited, and how eBPF will intersect with service mesh. So please check it out. I think it's a really good blog. With that, let's get to the episode of today, porting eBPF applications to BumbleBee. So Krisztian, for folks who are not familiar with BumbleBee, what is BumbleBee, if you can explain in a few sentences of your own words?
Yes, basically BumbleBee is a project by solo.io. It's a way to distribute your eBPF modules, scripts. Basically, you can think of it as a Docker for eBPF, basically, because it solves the distributional challenges and also the integration challenges of distributing your little eBPF scripts.
Yeah, definitely. I launched the BumbleBee website on the side so people can take a look too. So BumbleBee really focus on, building, publish, and run experience to help you get started with eBPF. In fact, it's one way for me personally to learn eBPF as well. So, very, very excited about BumbleBee. That's very cool. Let's move into my next question for you. What is new about BumbleBee? I noticed you've been working on BumbleBee for the past maybe two months.
Yes, I had some time and I checked out the repo, which is available on GitHub, and I wanted to get familiar with the inner workings of BumbleBee, what issues it solves, and how you can easily contribute to it. And I found that one of the easiest angle to address this question is to port some actual examples to BumbleBee. If a project has many examples, people can start exploring these in their own environment and play with these scripts. So I take a look at the actual scripts that was already there, and started my eBPF journey with BumbleBee as well, and ported, I think, 2 scripts to the repository, which was a great way for me to get familiar with the core concepts of eBPF.
Yeah, totally. I do believe the easiest way to learn is really to be hands-on. For example, I had to write my first Hello World program on eBPF, which is just to, without following any instructions out there, just kind of figure out how to do it yourself is the easiest way to learn. So, can you talk about what's on the roadmap of BumbleBee?
Yes.
Do you want me to bring that page or you have it?
Yes, we can also pull up the page. I don't have it open yet, but I think I can get it up. Basically, a great area for any eBPF application is to get proper integration with existing systems. This can cover distribution, and this can cover integration with other parts of the infrastructure as well. We can think about observability, for example, because there are some interesting challenges that can be solved with eBPF. Some of this cannot really be solved otherwise, or cannot really be solved the way that's efficient. So integration with these applications and technologies, I think, is pretty important. BumbleBee can integrate with Prometheus, for example. Currently, BumbleBee only supports the gauge and the counter metrics type, but for example, on the roadmap, we have the support for the histogram type, which would be a great addition because there are some already proven applications, eBPF applications, that are relying on that data metric type. And once we have it, we are ready to visualize all these new kind of observability challenges with the help of BumbleBee. And apart from this, we also have multiple other items. For example, we are working on adding new languages, for example, Rust and Go. And there's another request from the community, for example, to have support for user space probes as well. That's an issue. That's a frequent ask for many applications working in the eBPF space currently. Then there's the usual multi-arch builds and some quality of life improvements on the B CLI. We will explore the CLI at the demo in this session.
Yeah, that's great. One thing I would add on top of what Christian said is certainly the project is very new and it's pretty dynamic, right? Based on feedback. For example, a couple of us were traveling to Valencia for eBPF Day as part of KubeCon Europe. And as I was presenting about eBPF and BumbleBee to eBPF Day, one of the user in the audience, attendee in the audience asked, do we support cosign to BumbleBee, right, for BumbleBee images? And Eitan, who is a maintainer on the BumbleBee, actually just added that feature to the BumbleBee and even provided README on how to use that, right? So our roadmap depends on you to help us shaping it too. So that's a good example of based on the user, the audience ask, and we add it to the roadmap and then implement it too.
Yes, so if you have any request, please open a GitHub issue on the repository so we can take a look at it and plan with it.
Yeah, totally. Okay, so now I'd like to dive into the examples. Oomkill. So what does this application do? Why did you decided to pick this application out of the other applications?
The tool itself is about catching oomkills. You are most probably familiar with the oomkiller in Linux system and even in Kubernetes. And if you have experience trying to catch these oomkills for your applications, memory leaks in production systems, it might not be that easy. For example, from my time as an SRE DevOps engineer, I was having a hard time. I was having a hard time catching all these events and getting to the bottom of the actual root cause. So I take a look at the existing eBPF examples. I saw there's a oomkill example there, so I choose to work on that.
Yeah, makes sense. Certainly a very useful program. Can you discuss what triggered you? Why would someone wants to put their eBPF application to on top of BumbleBee?
Yes, as I mentioned, I used a script that was already written and it's available in an upstream GitHub repo. But if you want to take that script into production, you will have to work around many rough edges. You have to distribute that image. You have to. It's not trivial to get this into an image, and that might be a requirement for your security team to have information and for example to verify the origin of your script security wise. Also, the integrational challenges are quite rough currently. So for example, if you want to, let's say you are using the usual Prometheus stack on top of Kubernetes and you want to have an alert for your oomkill event, then your pure existing upstream oomkill script will not get you there by default out of box. You have to create Prometheus metrics from that. So these are the challenges that you can easily solve with BumbleBee. And on top of that, you can only just focus on the actual kernel space code. The generation of the application side, the user land code is taken care of by BumbleBee, which is another great advantage of using this project.
Yeah, definitely one less thing to worry about. Yeah, I think it will make more sense when we get to the hands-on demo portion, to see. It's just so nice that you don't have to change your application and get that observability information into out of memory too. So can you describe to us what's your experience supporting this example? Is there any gotchas? did you had a hard time? Was it pretty straightforward?
Actually, I think the oomkill example was my second attempt to port a script. So I had some very minor experience before that. Yes, the initial experience was not that smooth because there aren't many examples out there. If there are some examples out there, those might not follow the current best practices. These might not use eBPF or the compile once, run everywhere approach. So your code that you found on the internet might not work or might not have the best performance, and these are very important aspects to pay attention. So I had to jump around a lot, check documentations and existing blog posts, and the debugging experience was not that great as well. It's basically pure C, so you will have to inject little print statements into your code and read the value from the system pipe, which is not that convenient as you would expect. But this whole space is evolving rapidly, so probably in a couple of months or years, this experience will be simple. But BumbleBee is a great step into that direction, because with BumbleBee you can just focus on the user, the kernel space code, and that's much more focused on the actual problem that you are trying to solve. So there were some gotchas, but the experience is getting better and better. And soon we will publish a blog on this actual porting exercise, which will go into much more details about the technical choices and the technical limitation of each data type and all these technical things. So I recommend checking that post out when it's out.
Yeah, makes sense. So people can leverage your experience. Hopefully, it will be a lot easy for them to put their applications to BumbleBee. What was the first application you ported?
I think I was trying to implement a Hello World-like application where I'm just printing anything basically into anything, at the kernel space and reading it back from the user space. And after that, I think it was the exit snoop application, which is tracking the exit calls. It was fairly straightforward. The approach is a bit different than with oomkill. But yes, I think that was my first one.
Yeah. Okay, very cool. The next question I want to ask you, have you heard of this Cloudflare exporter? And what's your thoughts on, the difference between BumbleBee and this project?
Yes, Cloudflare has an eBPF exporter, which has similar functionalities to the functionalities of BumbleBee that is focusing on the Prometheus exporter side. One difference would be that the Cloudflare exporter supports the histogram metric type. So if you are loading eBPF scripts that are relying on that data structure, that can be handled already. But yes, I think the core focus of the two projects are a bit different, because while the Cloudflare exporter is basically the eBPF exporter is basically just an exporter focusing on exporting eBPF metrics in a Prometheus format, the BumbleBee project is more like about providing a runtime for your scripts and about distributing these modules in a very efficient and convenient way. Additionally, it could expose Prometheus metrics, but that's just the cherry on the cake, I would say.
Yeah, I guess that's a small piece of what BumbleBee can do, just the Prometheus export portion. Yes, agreed. All right, let's get to the demo then. I think our audience probably have been waiting for that. Should I bring up your screen?
Yes, we can bring it up. So as I mentioned, there will be a blog about all the technical details. We won't have time to get into all these inner workings of the script, but we will take a high-level overview of everything that's under the hood, and at the end we will deploy it on a Kubernetes cluster and access the metrics from Prometheus. So as I mentioned, I was using an upstream script. Let's first take a look at that. It's basically a fairly small script. It's 30 lines of code. We have some headers there. We have a struct here. And basically this is the main BPF logic to get the data for our oomkill events. The issue or the challenge with this script is that you will need to handle the userland part, as I mentioned. If you take a look at the libbpf tools folder in the BCC repository, you will see that all these examples are having maybe 2 or sometimes 3 files. One of them is the .bpf.c, which is basically the BPF kernel space logic. That's the main part of the actual application. Then there's the .c extension, which is the application side of things, getting all this data to user space and attaching, loading, and destroying the resources required to run this. And sometimes we also have a separate header if the data types requires it. So if we check the oomkill example, that was the file that we checked, 30 lines of code. That's our basic script. And if you check the userland section, we can see that we have all this code. Basically, we are parsing the arguments for the script. We are handling the events. We are handling the lost events. We are responsible for printing all this data. We have the main function here. We have all these fprintf statements here. And as I mentioned, we are also responsible for cleaning up all these resources that we have. As you can see, it's 180 lines of code, and the premise of BumbleBee is that you would not need to be responsible for any of these because BumbleBee can take care of it.
Well, that's a lot of code. In fact, that's more code than the eBPF program itself, right? The user space has like 3 or 4 times more.
It's more than 5 times. Yes, it's a lot.
Yeah, exactly.
So yes, download this file I just showed you, the .bpf.c, and let's compare it to the file that I made during porting this application. As you can see, there are some changes, but not that many, and we are only focusing on the kernel side now. First, I got rid of the oomkill.age header. That header only included...
Can you quickly explain which side is which for the audience?
Sure. Of course, the left on the left-hand side, you can see the original code, the .bpf.c. So this is the upstream code, and on the right-hand side, you can see our code. Yes, it's a few lines more, but the difference is not that much. So yes, I got rid of the this header, because this header only included the struct that defined the structure of our data. We are basically interested in the process that's getting oomkilled and the process that's currently running at the time of the oomkill. So we will need the name of these two comments. You can see those here. And we are also interested in the process ID of these two comments. And additionally, we can get the memory pages at the time of the oomkill probe is triggered. So basically, at this point, we have no real change at the code. We are just using a single file instead of referencing this header. The first difference is having a different map. There are various reasons for this. The first and the trivial reason is that BumbleBee currently only supports two map types. These are hash map and ring buffer. As you can see, the original code is using a different type. That's the, let's say, legacy map type. It's called perf buffer. So we are migrating to ring buff from perf buff because BumbleBee only can handle ring buffer. But the other reason for this change is that currently using ring buffer instead of perf buffer is the best practice because it can solve ordering issues. It's much more performant. So you cannot really think of it as a limitation. It's basically the current good practice to develop your eBPF code. There are some trivial changes because of this. You don't need to specify the key size. You just need to define the max entries that can be used in this map. You can think of this map, if you are not familiar with this BPF concept, as a queue, as a high-performance queue that you can write into from the kernel space and access all this data, all these events, all these fields at the application side. That's basically the structure's goal. Yes, for this type, we are using the data _t that we referenced earlier, and we are using a different name. The original code called it events, and we are calling it oomkills. That's just a minor detail, but it will be important when we are taking a look at the Prometheus integration, because when we are exposing all this data as a Prometheus metric, this name will be used to name the metric, so you can find it easier. So I thought it would be good to have a matching name for this script.
Yeah, so you want a unique name, right? So that it's the events from this program with events from any other program.
Yes. If you don't know what's behind this metric, you will just see the suffix events, and after a few months, you won't even know that what are these events. Yes, these are events, but these are oomkill events. You are free to choose any name, but I think using the proper name can make your life easier in the long run.
Yeah.
And I go into more details on the blog about this Prometheus integration logic, but basically the nice thing with BumbleBee is that it's taking care of all these metrics exposures. So basically you can just add the .counter suffix to your map. So if you compare these two lines, the difference here is not just the name, but the original has the .maps and our version has the .maps.counter. This will tell BumbleBee to expose this data as a counter type. So basically that's it. After this point, if the image is built and deployed, you can scrape all the content of your map as a Prometheus matrix. We will see that at the end of the demo. And after this point, we have the core function the core BPF logic. This logic will be triggered each time this kernel probe is executed in your system. So basically, your kernel has this K probe, and every time it's triggered, you can execute a little script, and the content of the script will populate this data type, and these events with this data type will go into your little queue. I think that's the simplest way of explaining the process of a simple eBPF script.
Yeah, so only when any out of memory process, kill process happens, right? This gets triggered, the K probe. And
yes.
when this is triggered, you essentially update the map so that your user program can have access, which BumbleBee provides.
Yes, exactly. The blog is going more details about each of these instructions, but basically, as I said, we are interested in these details. The process that's getting oomkilled, that's the most important one, and we can additionally get the process ID, and we can also get the process that's being run at the time of the oomkill, which might help to pinpoint which process caused the actual oomkill. So the logic at the two sides are not that different. There are some small changes at the beginning, at the end, and that's because our migration to ring buffer, because ring buffer, as I mentioned, is about providing a more performant way to handle these events.
Yeah.
In the ring buffer, you can basically reserve reserve the space in memory for your events, and if you could preserve it and populate all the data that you wanted, you can submit it and commit it. That's a simplified API on top of the existing logic. Basically, it's just a nicer developer experience to reserve the memory space and commit and submit this data. You can get rid of insufficient memory copies, and there will be no ordering issues if you are running on multiple CPUs and the events are arriving at a rapid pace. And as you can see, the changes are not that complex. Basically, we are just reserving the space, and at the end submitting this, and that's about it. Okay, so basically that's the difference between the two codes. As I mentioned, check out the blog for further details. So once we have the code, let's see BumbleBee in action and package this into an OCI image. To this, we will first download BumbleBee. Currently we are on .12 version, and it's already installed. You can check out the available options. If you're already familiar with Docker, most of these will be familiar, because you can basically build, pull, push into local or remote repositories, tag your images, and yes, basically the runtime is very similar. So next, we will copy our example into our local directory. So we have the oomkill.c locally in our current folder. This is the code that I just walked you through. Now let's build this into an image. At first, it can take up to maybe 30 seconds or so.
So I guess this is the compile the code, generate the bytecode just for the eBPF program, which what you just showed us, right? The oomkill.c generate to bytecode, and then we package it as an OCI image.
Yes, exactly. If we try to run this image locally, we will see if there's an issue with the code. You can test it locally. For example, if the kernel verifier finds something that not should be there, some issue with your code regarding memory access or performance, you will be notified and you won't be able to load it into your kernel. So it's a pretty safe way to play with this. I'm only using this lab setup because catching oomkills in your local system can cause issues. So let's use this lab, but you are free to experiment with this locally as well. Okay, so we have our image. Now we can push it to a local repository. I have a repository running locally, but you can use any OCI compliant remote ones as well. And once we have it, we can run it locally. If we would have any issues with our code, we wouldn't see the interface of BumbleBee. We would get an error of some sort. So if we see this actual interface, we are good to move forward. We don't see any events here because we don't have any oomkills in our system, fortunately. But we will simulate this after a couple of minutes. Oh. Okay. So to make this interesting, we will deploy this image on a Kubernetes cluster. I just installed and run and build this image locally, but basically we are running on a Kubernetes system. We have 2 workers and the master node, and we are currently on the master. So we can use this quick and dirty kubectl manifest, Kubernetes manifest to deploy this as a daemon set. If you deploy it as a daemon set, you will have BumbleBee pods across all of your nodes. So if you experience any memory-related issue in any of those, you will have the data. As you can see, the interesting thing here is that we have a single container. It's called BumbleBee. We are using a BumbleBee image, and we are executing the p command, which is the command of the CLI, and we are passing a few arguments like run, and we are referencing the image that we just pushed to our local repository, and we are exposing the ports so we can access this with Prometheus. If we check the pods, we will see that we have 3 pods up and running. Everything is working properly. So BumbleBee is successfully deployed.
I assume that security context privileged is true for running the daemon set because it's a eBPF program.
Yes. You need this security context to basically to run the eBPF code. It's a requirement for BumbleBee. You can explore all the prerequisites on the GitHub repo. There are details about which kernel is supported, so you can check all those there. If you are running on a very old kernel version, you might not be able to use all the features. And another information that we can call out is that, as I mentioned, BumbleBee is using the ring buffer map type, which is only available after 5.8, kernel version 5.8, I think. And the eBPF is available a bit before that, But to actually run these scripts in these forms, you have to have at least kernel version 5.8. But I will check the exact date. But I think that's the version which introduced the ring buffer data type.
I see.
Okay, so let's deploy Prometheus. We are using the Prometheus stack to deploy everything. We will just use the Prometheus interface, but this will deploy nearly everything. We are putting this into the monitoring namespace that we are creating now. It should take a couple of seconds, but not that many. Okay, we already have it. Let's check the pods in the monitoring namespace. Okay, we have everything up and running. If we go to the Prometheus UI, I think we should have the interface. I was a bit fast, but yes, one of the pods are not running. Not yet ready, but we will.
Yeah. Do you have to expose the service to a load balancer type, or you're just pour forwarding?
Yes, I will just pour forward it, and you are right. Actually, that is missing. Prometheus itself is ready. Grafana that's being that's currently in progress. Prometheus just not yet exposed yet, but we will fix that shortly. Before we expose the Prometheus, let's deploy a pod monitor, which is a custom resource of the Prometheus operator project. Basically, you can define scrape configs with the help of this abstraction. The logic here is really simple. We are just matching the BumbleBee application and referencing the /metrics endpoint and the scrape interval, and we will get the metrics. So let's deploy this as well. And after this point, we can expose the Prometheus interface. And voila, we have the UI.
Yep.
Now we should just wait until the config will be populated into the Prometheus config map, and we have the scrape config ready. We should see BumbleBee targets coming up. BumbleBee, because we have 3 nodes.
So would you just see 3 BumbleBee or just 1?
I think we should see 3, because this config will match all the applications that are labeled this way, and because of the daemons that we will have 3.
Okay, because it's a pod monitor, so we have 3, I guess, replica of the pods. Oh, yeah, right. It's coming up.
Yeah. We already have 1, and the other 2 should be ready soon. Okay, we have 3 pairs 3. So we have all the we have access all the metrics that are exposed by these pods. So next, let's deploy an application that will leak memory and cause an oomkill event. We will use this sample application. And if we check the pods, we should see the oomkill itself as well. Okay, we can see a crash loopback, but I think if we use get pods, if we refresh this, we will see the actual oomkill as a status. Okay, oomkilled. So our application is getting oomkilled and it's in a crash loopback. Now, if we go back to the Prometheus UI, we should, let's refresh this just to make sure. Let's search for our metrics.
OOM, yeah.
Yes, and as I mentioned, the suffix of this generic part is the name of our map. So if we would stick with the events, this would be eBPF solo.io events, which is not very useful on the long run to identify these oomkills. So it's better to have a proper name for it. And if we execute this query, you will see that all this data that we wanted to extract from our events are basically there. And we have a 1 as a value because we had an oomkill for these events. As you can see, that's the tcom. The tcom is the name of the process that's getting oomkilled, and the fcom is the name of the process that was running at the time of the oomkill. We also have the corresponding process IDs, and we also have the memory pages. One thing that can be a bit misleading is that we are currently running a Prometheus stack on top of Kubernetes, and if you are running that, you most probably are running that, you will have these default Kubernetes labels: container, endpoint, job, and pod. And actually, if you check these, you will see that you have the BumbleBee pod as the value for your pod label for this oomkill matrix, which can be misleading because not your actual BumbleBee pods getting oomkilled. That's not the pod that's causing the oomkill. That's just the pod that's exposing this matrix. So basically, that's just a UX thing, because correlating with the actual pod requires a bit more eBPF work. So yes, currently with this quick proof of concept, you can just have the actual name of the process that's getting oomkilled and the process ID. But in this case, it's called stress. But for example, if you are running, let's say, Node.js application and you see Node.js as the oomkilled process, then you can probably easily pinpoint that your frontends are having trouble, or that might not be the best example. But for example, based on the actual process name, you can probably filter down the actual issue and root case.
So question, the instance that 10.42.0.5, is that the pod that dies out of memory, or that's actually the daemon set co-located, the BumbleBee daemon set co-located with that pod?
Yes, exactly. That's another that's another thing that can be a bit misleading. The instance is the actual node. So for example, we are running this as a daemon set, so you would have all the nodes here as the instance, and the port is the port that BumbleBee exposes. In this example, actually, you can only see one of the instances, and that's because the pod,
because it's always that one, right? Co-located with that pod, because you have 3 BumbleBee daemon set instance, but only one of them are co-located with this pod that runs the stress.
Pod, yes, exactly. That's getting oomkilled. So yes, that's another good thing to point out, to call out. Basically, you can find the node which was hosting your problematic application.
Yeah, and you have 4 instances. Sorry, just a quick question. You have 4 instances here. Is that because it restarts like 3 times maybe? And every time it has a different PID ID?
Yes, we have that many value for this matrix because the process IDs are different, and it's not trivial to pinpoint which process caused the issue. Basically, we just took the upstream script without any fine-tuning. I'm not sure the original upstream script was written to focus on Kubernetes deployments. So this data can make more sense in a, for example, in a bare metal environment where everything is running on the actual host. In that case, it can provide better data, but you can fine tune the BPF, the eBPF logic to get rid of this noise that's being generated. And that's another good thing here, that with BumbleBee you can focus on iterating your kernel space code and the application, and you would not need to touch the userland bits for this experimentation. In this example, that's a fine example that you have some data, it's working, you can find the actual process that's getting oomkilled. The result is not perfect, but you were able to go up to this point in a fraction of the original time that you would need if you would go with any other application. So you can just iterate on your BPF code.
Yeah, it's so much better than not having this data, right? It's at least tell you what process and the name and the process ID. So, and also it tells you the IP address, which you can find out on which Kubernetes VM, right? So that's helpful too. Yeah. All right, this is really cool. I want to ask you, is there anything else you want to show or add? You mentioned a workshop.
Yes, as you can see, it's the usual Instruct platform that we are using to host our workshops, and we have a beginner eBPF lab that you can enroll to and have a certificate even. We are currently working on another eBPF workshop that will be focusing on the actual on developing eBPF applications, just like this one. So yes, you will see some information about this when it will be ready. It's currently a work in progress.
That's great. So once you have your blog published and the eBPF program, which I think is an intermediate program built on top of a fundamental for eBPF by solo.io, we're published in the comments of the YouTube so that you guys can have access. So this has been wonderful. I feel I learned a lot more about eBPF and BumbleBee myself today. So Krisztian, I want to take a minute to thank you for your time to tell us the story of you porting oomkill application. What are the things you watch out for, and also show us a real cool demo of how this works with BumbleBee to allow users to instantly get the data about which application have generated out of memory events. So very cool. With that, we're going to wrap up. Well, thank you all for joining us today. I hope you find this useful. If you like it, please click on the like button and subscribe to our channel so you don't miss any of our future episodes where we talk about different cool things in the cloud native technology lands. Thank you so much. And thanks again, Krisztian.
Thank you for having me. Thank you for joining.
Yeah, thanks so much. Bye now.
Bye.